Hello everyone, Bradley Sward here, and this is my solution to part 1 of day 6 of the 2024 Advent of Code. The problem is guard Gallivant. I'm solving it in Python almost as always. So here's the problem. It's actually pretty straightforward from a top-down design, high-level design here. You have this little caret for where you have a position for a guard who's walking around in this virtual space. And you can see that when he can walk up to and then hit a thing, and then every time he hits something he turns 90 degrees, and then he hits here and he goes 90 degrees, and so forth and so far. And when he walks off, somehow he's going to eventually walk off of this thing, and the question is, when he does, how many squares will he have touched on this gameplay until he gets off from where you start, from where you go. And so, again, from a top-down design here, pretty easy, but here's the code that I use to get it to happen. So I basically, my setup for my array, or is an array of a list of lists, or a list of string characters, one by one by one. So this unpacks everything into it, and then this function here, when I go to check the array later on, or the list here, if it's out of range, it'll give me an empty string instead of throwing an exception or doing anything crazy. Otherwise, it'll give me the actual value it needs. So then now, with that in play, now I can just go ahead here and just say, from this standpoint here, up is a -1 and 0, at least in my coordinate scheme. And then if I turn 90 degrees from there, the coordinate would be 0 in the x, and then +1 in the, or positive 0 in the y and +1 in the x. I'm not used to reversing my x's and my y's, but somewhere along the line I did. But anyway, so that's each of the 4 directions, and then you can come back around if you need to. When you come back, if I turn 90 degrees from here, I'll come back to this one. But here, say, as long as whatever square I'm on is not an empty square, meaning I'm off the board, well, let's do something about it, because we're on the board then. And we're saying, like, well, this is where I would go if I could walk one more square from where I'm standing in the position I'm facing. And so there's the dy and the dx. And then from there I say, well, if it's a dot or an x or an empty square, well, then go there. You're allowed to go there. But if it's a dot, turn it into an x, because that is on the board. Otherwise, you're already on the board. But if you're off the board, well, we don't care. We only increment 1 whenever we turn basically a dot into an x. And that's why we start with the total being 1 here, is because we're turning the caret into an x, because you're starting on that square. But otherwise, then you're setting the dot to an x. Otherwise, and then move there, and then come back again, and then you keep moving until you hit one of these guys, where you're like, well, if I hit one of these guys, then I want to turn, like we talked about, and then the modulus operator gets me to come back around. And otherwise, if it's the space at that point, right, what would happen to the empty if you're off? You would come here, you'd say, okay, empty string. You wouldn't change anything, and you would go there, and then when you come around, the current would be an empty string, and then we'd fall out of the loop and print. And as you see here, I get the 5153 that the program is expecting of me, that my system is expecting of me. 5153 right here, and then part 2 I'm going to take a look at. I just wanted to get part 1 of the books before I thought about it. So thanks for sticking it out with me as always. Hope this helped for any of you looking. If you know a better way, as always, please let me know. Have a good one. Thanks, everybody. Take care.